is about that time. Good morning, everyone. Thank you so much for being here today. We truly appreciate your time and the interest in our presentation. My name is Sammy, and I am excited to get things kicked off. I'd like to introduce our presenter today, uh, Glennon Bagsby. Thank you so much, Glenn. Go ahead and take it away.
All right, Sammy, thank you. Thank all of you for coming out. I appreciate you taking a little bit of time to hear about the New Era software product, the Control Editor. There's been a lot of discussion and uh, things written both online and in publications about compliance with different regulations, not only here in North America, but also in Europe with the DORA regulations and a few other things. And so what we wanted to do is put out there to you that there is a solution available with the control editor to help you minimize the effort to get in and stay in compliance with these regulations. And so what we're going to do is just do an overview of the control editor, kind of using this idea of compliance and the regulations as the framework for the overview. But we'll talk about some of its capabilities in general as well. So the control editor basically provides the ability to provide an additional level of access control and change management for resources or elements that have been defined to it. These are Unix files, traditional data sets, PDS, PDSE, sequential data sets, and also load libraries. And what it's going to allow you to do is to set extensions to your external security manager. This includes validating the identity of the person making the request to affect a change on that element. So if someone logs onto the system and says, I'd like to access ProcLive or PalmLive, that's fine. If they're allowed by the external security managers to do that, they're going to get in and be able to do it. But one of the things that these compliance regulations, primarily the zero trust one here in North America, stresses the fact that we have to assume that the credentials have been compromised. So if the only thing we're doing is checking user ID and passwords and even adding an MFA to that, that's really not sufficient because we really haven't tested the identity of the person making the request. We know that that person has the credentials because they supplied them, but is it really who they say they are? And that's part of the problem that they're trying to address with primarily, again, the zero trust regulations here and a little bit of DORA as well. DORA looks at it more from a data standpoint, where zero trust looks at it more from a standpoint of access control. But we're going to put in place method to identify and confirm the identity of the person making that request, and also enforce site standards for things like documenting the event. Why are you making this modification? Why are you submitting this particular job? What's the reason for that? What are the instructions if I'm making a change to back that change out? And make sure all those things are part of the process, as well as whether or not it's been approved. And if there's a change request number or some other identity of this particular event, make sure it's captured with the same documentation and stored away for reference later on. The control editor also, as I said before, extends the controls that are set by the legacy security systems. So we can do a more comprehensive level of protection against those critical resources. It's not something that you want to do across everything. So it's not going to be a one-shop all kind of a thing, but it is designed to allow you to put this extra layer of control over the most critical elements within the environment. So when we're talking about the mainframe environment, we're talking about parm lives and proc lives and serve auth settings and RACF and the pageant definitions and other things like that that might be defined in TCP/IP. So these are the things that we want to be able to put this extra layer on. And it's a way of doing it without changing your security environment. So you'd have in place still whatever you've got there going and testing and protecting, but this is a way of extending it so we can add and make sure we're in compliance with these different regulations. We also provide, obviously, the ability to analyze the data that's captured and the controls that have been executed by the control editor. So there's going to be notifications sent whenever something occurs. by email or by a message back onto the screen or to a WTO. There's going to be records created into our own journaling system so that they could be extracted and reported on either on a continuous repetitive basis or on an ad hoc basis or both, so that you have the ability to do forensic analysis if something is not correct or something has been changed that you didn't expect or if something needs to be backed off. You have the ability to go into the journaling system with query facilities to understand all of that. And it's not relying on some other kind of legacy data. So it's not going to post process SMF or anything else like that. This is all real-time data capture going into the journaling system and the actions that we're directed to do, like send off the emails or send off warning messages, so that you have a complete understanding of what's happening in a real-time mode and not waiting for an offload or an extraction of running through several million SMF records to find the one or two that you need to see. So that's a very important point about what we're doing with the control editor is to make the data much more accessible and available, and as a result, more valuable to you that we're storing away within the journals. So the control editor provides these things by looking at some capabilities that we've added. One is called multi-factor access control, or MFE, for multi-factor edit. But basically what it's doing is, as I described, validating the identity of the person making the request. And more about that as we dig a little bit deeper in. But we also found some weaknesses that exist within external security managers, and one of those is member level control. So if you want to set up access at the member level in your RACF installation, it's not really practical. It's something that you can't easily implement. And even with the other two, top secret and ACF2 or TSS and ACF2, it's difficult to implement and to manage and maintain. With the control editor, that this is very easily done to identify not only access to it, but also what the particular user has rights for against that particular member within that particular data set. We set up email notifications, again, broadcasting to whoever needs to know events that occur that somehow affect or use that particular data set or load library or Unix files or the members contained within them. So we have all kinds of way of making sure that we understand and we're notifying people what's going on. And then we also, again, enforce standards about documentation. So when the event occurs and it's supposed to be documented in a certain fashion, we can enforce that. We can present the document field back to the user and they have to fill it out properly in order to proceed. And I'll have a few minutes at the end to show you just what some of this stuff looks like in a short demonstration. But all of this is automated as much as we can, so that if a change is made to a particular member that's being protected by the control editor, it will automatically make a backup of that and store it away into our journaling system. It will create different versions of that member, all with the same member name, so you have complete history of the change events that occurred for that, or the use of that if you're capturing things like submits of JCL members. That can all be stored away into the journaling, so you can see all the events that occurred. This allows for easy compare and restore functions. So it's easy to say, well, I need to go back to the way it looked a month ago or last week or even yesterday or this morning. The history is automatically stored for you. You don't have to do it as a separate step. So the user doesn't have to remember to make a backup or fail to make a backup purposely because if they go, oh, this is trivial, I'll get it right, no big deal. This is done automatically so you have assurance that you have the different versions stored away. And then again, the ability to query those records or those versions and do the comparisons to look at them. And we do that automatically for you as well. So if when you enter into a member that's being protected or a data set that's being protected or a file, and we see that it's different than what's stored away into the journals, we will immediately notify you that and give you the opportunity to capture a backup before you begin to make your modifications or your submit or whatever action you're taking, so that we always have a current version of that stored away within the history files in our journaling system. Now, to look at this kind of graphically, in a normal TSO RACF environment or ACF2 or top secret, it doesn't matter. The user logs on to a TSO ISPF screen. And I'm using TSO ISPF in this example But the control editor also covers changes made in batch mode or in some other method where the content is altered of the data set or files again. So I'm using ISPF because it's obvious and easy to explain. But think about it in terms if you're submitting a batch job and you make modifications or an FTP process or something where the content is being altered, that will also be captured and reported by the control editor, but I'm going to not have time to show you all those examples. But in this case, someone logs on to the terminal and we'll call him Tom. Tom's logged on and he logs on, he passes the validation from the external security manager, and he has available to him the rights and privileges assigned to him by that external security manager. That's the way the world works. That's the way it's worked for decades. And this is the part of the problem that they want to solve with these regulations is to tighten this down further than having the identity by having the identity checked and also understanding the relationship of that particular user against a subset of the group definitions that may exist. So Tom, if he's a systems programmer, he may be have the same privileges as another system programmer, but he may not have the same skills or the same experience. And so, what we need to do is be able to isolate down just those responsibilities that Tom has and only allow him to have access to those things that he needs access to, even though he may have a much broader access rights from RACF or the external security manager granted to him. We need some way to identify that and focus that down. And that's what, in the case of the NITS uh, regulations, uh, the zero trust in particular, it talks about something called dependency mapping. In the bottom right, I've added that on here, where it's actually saying we need to understand that that requester may be allowed to a much larger universe of resources than what his responsibilities call for. So we need to be able to map that user to a subset of that. So in this case, Tom may be responsible for message suppression, and so we need to give him access to the MPF LST member or the automation routines, but he doesn't need to see the prog member. He doesn't need to see the SMF member. So how do we fence him off from that if he's in the group that gives that group access to that because others do need that access? So this is what one of the things that compliance starts to call for is this identity, identifying the relationship between the user and the actual resources, or if you will, the role that user has for controlling and accessing those particular resources. Now, the other thing that comes into play here that these regulations call for is again the ability to not only validate the relationship between the user who's logged on and the actual resources that user requires in order to do their job, but we're still back to the question about if that person logs on with Tom's credentials, how do we really know if it's Tom? Because it could be somebody that somehow compromised his credentials. And if you take the time to read through all the zero trust regulations published by NIST, you'll find out that there's a section in there that deals directly with that, that talks about we need a way to establish the identity of the user so that because we expect the credentials to be compromised, that somehow they've got those in falsely. So if they're going after something that's not critical, then maybe we don't need to worry about that. But certainly if they're going after the ParmLib data sets or the ProcLibs or the pageant definitions or the TCP/IP port assignments, whatever that are out there, we need to protect those to a higher level so that we need to confirm that the requester is who they say they are. And that's part of what these compliance regulations are pointing to. They want us to understand this by doing excessive access checking, where we can confirm the identity of the person making the request. And in the mainframe world today, I don't know of any other product except for the control editor that gives you that ability. And what we're talking about here is something that we're familiar with and what they're asking us to implement on the mainframe. And that's something called sophisticated verification. So sophisticated verification there's a lot of words on the screen, but basically it's something we're familiar with. We all know that if we log on and get a credit card or log onto our banking system, the first time we set up our account or our identity for that website or that web service, there's a high probability they're going to ask you a bunch of security questions. What was your mother's maiden name? What year did you graduate from high school? What was the color of your first car? And all of these things are stored away within the system as a way to check your identity if you come back later on and want to do something that's riskful, something that has an impact on yourself or on the business or on your money or whatever you're going after. They want to try to invoke that on the mainframe as well, so that when Tom logs on and he tries to get after one of the resources that he's allowed to, but it's a sensitive area or it's critical area, we want to confirm his identity. So we want to have a way of taking a bit of information that Tom only has access to and test him to see if he has that answer. And if he does, then we'll let him proceed. If he doesn't have that answer, then he's not Tom. This is after we've passed RecF and got access through it or other the external security managers and or perhaps even an MFA. But we want to make sure that it's really Tom doing this. So we want to put in a verification process where the system can ask that personalized question back to the user based on some prior setting. And if it's not him, if it's not Tom in this example, then we're not going to let him go because we assume that his credentials have been compromised. Now, the way we do that with the control editor is adding a little bit more to this process in order to challenge the person sitting behind the screen and to record it and put things away so that we have history and factuals and auditability and all the things that the control editor can do. So one of the things that we want to do is as Tom makes his request, is see what that request is. And if that request is going after a resource that we've set extra protection against, we want to be able to challenge Tom to confirm his identity. And the way that that's done is we invoke the external security managers and ask us to give back a one-time token. And this token would expire after a certain amount of time. It's not repeatable. So if someone's even looking over his shoulder, they could not use it the next time. This token then is passed back to Tom in a variety of ways. One, it can be strictly an email, goes back to Tom, or a text message to his phone if you want to do it that way. Or you can take the token value that's being generated by the ESM and break it into two pieces. And so we're going to take the last four digits of the token and call that the suffix. We're going to store that suffix away in the challenge window, just like we did the full token if we did it by email. And those are the answers he has to give us. But if we break it in two pieces, Tom has to provide us the other bit of information, which is the private PIN that he has previously stored away. So those would be the first four digits of the token. So him combining what he knows with the private PIN he's stored and with the four digits that the token generator presented to him, he can then put that in as the answer to the challenge question. And if he's got it right, he will be permitted in and be able to continue on doing whatever his request may be. So in simple terms, Tom logs on and says, I need to go into ParmLab and I need to change the SMF member. And if he's allowed that by the external security managers, he's there. He can get to the SMF member. But the MFE challenge says, is he mapped to that? That's his request. But now, and RACF says he can go, but the mapping that we've done with the control editor may stop him because he hasn't been validated. Or the control editor has other controls in where we can test his identity. One of them is to ask for an extension of the password facility. So MFE can just simply put a password on that resource that Tom would have to know the password for and give it to it. And that's a very simple process to do, but that password is stored and encrypted in the system. But it might be anybody that needs to get to that data set has to know that password. It could be that we're going to go through this token process and we're going to generate out a token from the external security manager and send that to Tom's email. Tom would have to go to his email, pick it up from his email, put it back on the screen to satisfy the challenge, and then he can proceed and go forward. If I don't want to send it by email, or if I want to get more strict, I can actually divide it into two pieces the way I described and have Tom put in what he knows versus what was given to him, and those two would satisfy the request. And optionally, we could actually send that token to a different individual. So instead of sending it to Tom directly, we could send it to Betty, who is his lead or his manager. Betty, in turn, has to give it to Tom, and Tom's the only one that can use it, and it would expire again in a little bit of time. But the idea is now we have an extra layer of control over that, where Betty's now involved to improve the action that Tom is requesting, because she has to give him the magic keyword or token in order to pass the test. All of this is going on as part of an extension of the external security managers. Please remember that we're not replacing it. We're extending, and you had to have passed all the external security manager controls first before this process is turned on. Now, everything that the control editor is doing, all of its monitoring and managing, capturing changes, all of that information is written into our own control journals. And it's written in a way that we're storing a lot of valuable information. Some of it has a long-term value. So if I want to go back to way something looked a month ago or a year ago, I can store all that into the journals. Some of them have a short-term value. In other words, they're only usable because I want to look and see if something happened last Friday that I need to deal with. But by this Friday, it's ancient history. I don't need to know it anymore. So I have control over that data that is contained in the journals. But again, it's a record-keeping system independent of SMF or anything else that's out there. So it's easily accessible and much quicker to see and present answers to you with immediate notifications coming out in terms of emails and notices and stuff. And those things are also documented and written into the journaling file. Those journaling files I see on the list, some of you are customers that are out there, so welcome. And if you're using the control editor, you're used to this concept of journaling. We've got an improvement in place where the journals now can be automatically compressed and consolidated, backed up, and released so that all these new functions are available to you. If you're interested in this, let us know because it is brand new. We're just starting to push this out now, but it's a way to automate the management of the data within the journals based upon user-defined criteria about content, length of time, and things like those variables about the data that we store in the actual journals themselves. Now, I'm going to cut over to a TSO ISPF session and show you a little bit about what the actual control editor looks like to a user. So if I go into, excuse me, when I get back here, to an edit process, and I want to edit one of my controlled data sets, one of my test data sets, what's going to happen is the control editor interfaces with TSO ISPF in this example. Again, batch is covered, so is FTP in different ways. But in this case, we're actually tied into ISPF, and we can see what's happening. So if I select a data set that's under protection of the control editor for edit, it gets called in the background, and it's monitoring what I'm doing in this particular session. So if I come in now, I want to change that particular member. The first thing it's going to do is see if I have a current version of that within the journaling system. And if that version that's in the journaling system matches the version I just opened in my edit window. If it does, it's happy and it let me proceed. If for some reason they did not match, which would be a very rare occurrence if the control editor is fully implemented. But if it did exist, it would put up a window and tell you that and give you the opportunity to either do a new backup or go directly into edit and fix your problem or whatever the scenario would be. But it notifies you that it will make a new backup for you before you even begin. So now it's monitoring this, and if it detects that I make a change to this particular member, so I'll increase the number 1 or number to 5. When I save this, it invokes services. These services are optional. In this case, it puts up a display of the documentation that's appropriate for this particular activity. You have different forms for different activities against different resources, and those you control those forms through the control editor panels. It's very easily administered. So in this case, I have a request put up to give a change request number, a project number, some kind of approval number, some kind of tracking number, whatever you have can be implemented directly in the change at the change window, and it has to be done properly. So this is an ISPF panel, so I can test for content, whether or not it's alphanumeric, whether or not it's enough characters in the descriptor, all these things, all this detail, but it's a standard form that has to be filled out if I change this particular data set. Once I've made this change and did it correctly, I can then save my alteration or my improvement for that particular member. And optionally, I could send off an email. At that moment in time, when that action was confirmed, an email went off to different people that are aware of this activity or should be made aware of this activity so that they know that that particular resource was just altered. And so it gives me the ability to test and see those things. This also is an example of getting into the different data sets and testing them, playing with them, seeing if there's anything wrong. But I have rights granted by the security system themselves. If I go back up to the prog member, the control editor, for those of you who might also be image focus customers, performs the same ability in order to test the viability or the integrity of the member. And so we can actually inspect this member here the way you do inside image focus to confirm that the statements are syntactically correct, that the referential integrity is there, and that the member is ready to be used, or if there's any issues or problems with that particular member. You can see I got a bunch of notices in here because it's a data set that, or excuse me, a member I don't really use. But the idea is that while you're in edit, you have different services available to you. And those services are not only to save it and document it, but also to look at all the history. So we go back to a restore point to find out which LPARs actually use this member by going across the sysplex and looking at that. The inspect I just did. JScan is the equivalent to type run equals scan, but you don't have to modify your JCL. You simply type JScan or PScan if it's a proc. And it gives you the ability to really use these services while you're still within the edit window and looking at the edit content. So again, going back to the inspect logic, if I make an improvement and I'm not sure I spelled it right or did I get the X in the right column or whatever questions I have, I can inspect it before I save it and make sure that that is a valid member and accessible and can be used. So that's what the control editor is doing for me from a standpoint of in my edit activity. But if I go up now and look at a different data set where I have different rules applied, I can come in and say, I want to go in and look at this particular member. And what it should do is come back and say, okay, this one's got a higher level of protection. It knows who I am. I've, and I'm in the system. I've been granted access to this particular data set. But it also said that if you want access to this data set, you have to supply a token value that was generated. And this goes back to the discussion I had on the other slide. It was generated by the external security manager. In this case, in the option, I've said put it out back on the screen for me, but send the token to my email address. And once I get that token value, I can put it on the panel and it will give me access or not. So I have no idea what the token was. I didn't go look, but it stopped me because I didn't give it the proper token. So goes back again to a second level of confirmation of the identity. This could have came to my cell phone or to my email, or it could have gone to Betty, who has to give it to me. And then I have the token and I can put it in. Or again, it could have been divided into two pieces, in which case I could have provided the summary or the suffix that was given on to me by email or by text message and the information I know and put that into the system for my token. Now, in this case, I have it running in warn mode. I don't know if you caught that, so I was able to get into the member anyway. But as I make my changes, once again, this will be documented in either the similar or a like fashion. I can set up different panels, different documentation requirements for different data sets and different categories of data sets. Then that last step is to come in and actually test the correctness of a member again by doing the inspections and so on. So, excuse me, let's go back in and edit this guy and we'll pick him. And now what it's doing is going off and again, it wants a token value. It should fail. I'm in edit mode and it let me in. So the idea being is that I have control over access rights and against access to the particular members as well. So if I didn't want access to this particular member, I could put security on that says, no, you can't do that. Or I can put different tokens on different members. I have the ability to set these controls not only at the data set level, but at the member level as well. So the idea being is that the control editor is going to give you the ability to put in those things that are required to assert more control for access control and usability control uh, against the most critical resources and the most critical uh, files that you have on your system. And that's what's going to let you both meet the compliance requirements as well as stay in compliance with those different requirements. Again, if you go back to the logic I laid out in the prior slides about the sophisticated verification step, that's something that I don't know of any other way of doing. And people who are saying that they have a solution for the zero trust architecture using RACF, ACF2, or top secret, they're struggling to get it done because they're not meeting all those requirements, which includes that idea of excessive access checking. Now, I wanted to talk about a couple of things because the control editor knowledge that's stored away into the journals also is available through another product called ICE Direct. ICE Direct is a web-based application that takes all the knowledge stored into the journaling system by the control editor, as well as all of the inspection logs from Image Focus. So those of you who are Image Focus customers, you should be aware of this as well. And it puts it into a web-based application that's very secure, highly secured, can run under ZOSMF as well, but gives you the ability to do additional analytics and post-processing of the logs of the journal records for comparison and detail, and gives you all kinds of query facilities with the things you expected from a web interface with colors and icons and point and shoot and all those other kind of wonderful things. That's a separate webcast. If you want to come out and learn more about that, let us know. The other thing that the control editor helps with is that if you're looking at putting a process in that's called sometimes val boot, validation boot, validated boot, excuse me, secure boot, or list directed IPL. These are steps that eventually create out a very secure IPL text. This is something new IBM's announced, and we see some people starting to try to implement this so they can have this list directed IPL structure enabled to them. The control editor will protect those resources in all stages. So if you're doing val boot or secure boot, and with adding certificates and all those things that go along with the process, it can secure the content of the list directed IPL as well. And Image Focus supports the inspection of all these processes as well. And there's another application that we've built called val boot, which basically helps you automate those steps. And through that different logic that you go through, starting with the download of the operating system itself and building up your IPL text and doing the secure boot and validated boot processes and leading to the actual building of the list directed IPL structure. All of those can be automated or led through by this new application. So if you're going down that path, you might want to come back and want to talk to us about that as well. So once again, the control editor is part of the environment, the integrity controls environment. That the other major product is Image Focus. but we have the Ice Direct application and the Valve Boot application as well to help assist you in creating out those the IPL components or elements and protecting them during their lifetime and during their usability on the system. So I've reached my time limit. We're trying to set this to approximately 30 minutes, and I'm just over by a few. So I appreciate all of you coming out. There is the ability to ask questions if you want to unmute and speak up, or you can use the chat box if you can find it on your screen and send it in, or certainly reply back to support@newera.com with any questions or requests. If you want a more detailed presentation for your team to learn more about these products or understand exactly how all this can help your organizations, reply to Sammy or to support@newera.com, and we'll be glad to arrange that. So, Sammy, let me turn it back over to you and thank everybody for coming out and spending the time. I appreciate it. Thank you.
Yes, thank you, Glenn. Thank you for sharing such valuable insight. Thanks everybody who joined us today. I really appreciate your time again.